So, good afternoon, everyone. Welcome you all for DSY NT lecture. So, this is the lecture number 10. So, in the previous lecture, we have solved the numerical example based on the Thevenins theorem. We have solved the type 1 examples based on the Thevenins theorem. So, today we are going to solve the numerical examples which are based on Thevenins theorem only, but of type 2 or method 2. So, as per discussion in the theoretical part of Thevenins theorem, we have to classify the given network into two types. Either it belongs to type 1 or type 2. So, in the type 1, the network consisting of all sources as a independent sources. तिथं एक पण डिपेंडंट सोर्स नसतो, सगळे सोर्सेस इंडिपेंडंटच असणार. दॅट इज द टाइप 1. So, in the type 2, at least one independent source and at least one dependent. म्हणजे इंडिपेंडंट तर एक कंपल्सरी पाहिजेच, त्याच्याबरोबर एक जर डिपेंडंट सोर्स असला मिनिमम, that network we have to classify as a type 2. So according to the steps of the type 2, we have to apply to find out the Thevenins equivalent circuit. We have to apply the steps one by one. First of all, we have to find out VTH. Then we have to apply we have to find out short circuit current ISC, and after that we have to find out the RTH. कारण डिपेंडंट सोर्स तुम्ही शॉर्ट करू शकत नाही किंवा ओपन करू शकत नाही. So to then it is difficult to find out. In that case, RTH, how to find out, that becomes difficult. So in that case, we have to use the indirect method. So VTH, as usual, we have to find out open circuit voltage between two terminals, and after that, instead of RTH, we have to find out short circuit current, and then you have to find out the RTH. So I will share the PPT what we have discussed for type 2. The screen is visible. PPTs are visible.
Yes, sir.
Okay, so this is what the method 2 or type 2. So in the step 1, we have to identify the two terminals. If they are already given in the circuit, mentioned in the circuit, you can take as it is. But if not given, then you have to identify based on the question, based on the which parameter they are asking to find out, whether voltage across any element, current passing through any element. So that element you have to consider as a load, and you have to remove that, and those two terminals you have to make it open. That is the first task. If already two terminals are open, then there will not be any problem. So that is the step 1. And with respect to those two terminals, you have to find out the Thevenins equivalent circuit. The next one, step 2, the find Thevenins voltage VTH across two terminals of the above network. म्हणजे काय करायचं इथं? So you have to find out the open circuit voltage between A and B. Already we have solved the examples based on the type 1. So you know that how to find out the VTH. Now next, step 3. If you are comparing with method 1 or type 1, the step 3 is directly calculation of RTH, that is equivalent resistance between two terminals. But here you cannot find out the equivalent resistance, because dependent source you cannot make it short or open. You have to keep those dependent source as it is in the circuit while calculating the ISC, or we can say RTH. So short circuit, you have to connect the two terminals by short circuit, and through that, what is the current flowing, that you have to calculate. That name of the current is ISC. SC is for short circuit. Next, once you get the VTH and ISC, then in the step number 4, simple calculation, that is according to Ohm's law, RTH is equal to VTH divided by ISC. Now you got VTH here in the step number 2. In the step number 4, you got RTH. Now it is easy to draw the Thevenins equivalent circuit, because Thevenins equivalent circuit consists of what? The voltage source VTH in series with resistance RTH between two terminals, whatever the names A, B, C, D, 1, 2, like this. Once you get the Thevenins equivalent circuit, then you can connect the load resistor if it is given in the circuit. Then next, find out the current passing through that load resistor, voltage across that load resistor or load impedance, whatever the question is there. According to that, you can add the step number 6. So this is what we have discussed in the theoretical part. Already we have completed the numerical example. I think 3 examples we have solved in the previous lecture based on the method 1. Now today we are going to solve the examples based on the method 2 and Thevenin's theorem. Okay, so we can start now to solve the numerical example. For that purpose, I will share the whiteboard now. Okay, so numerical examples. First of all, I will give the heading, which theorem we are using. Thevenin's theorem. Thevenin's theorem. Numerical examples. Numerical examples on type 2. On type 2. Okay, so type 2 means what? That I will write here. Type 2 means what? Type 2 or method 2 means at least म्हणजे कमीत कमी एक independent source पाहिजेच. At least one independent source. One independent source and at least one dependent source. At least one independent source and at least one dependent source. If it is there, then we have to classify that network into type 2, and according to the steps of type 2, we have to apply the Thevenin's theorem to find out the given or asking parameter. Now question 1 we can take. Question number 1. Just simple, we can start. Simple question, we can take the first one. Obtain Thevenin's equivalent. Obtain Thevenin's equivalent circuit. Obtain Thevenin's equivalent circuit for given network or given network between terminals A and B. So this is what simple question. Just they are asking to determine the Thevenin's equivalent circuit between two terminals A and B. So this is the circuit. This is what 8 volt. This resistor is 4 ohm. This is what current source. So dependent current source, dependent voltage source, how to identify? कसं ओळखायचं ते सिम्बॉल वरनं? कुठल्या शेपचा सिम्बॉल असतो त्यांचा? Yes, diamond shape. Yes, very good. So it is diamond shape, and in that plus minus polarity, if it is, then it is voltage source. If the arrow is there, then it is current source. मग परत सेकंड क्वेश्चन काय असणार आहे माझं, की कुठल्या पॅरामीटर वरती डिपेंड आहे? व्होल्टेज वरती डिपेंड आहे का करंट वरती डिपेंड आहे? सो दॅट डिपेंड्स ऑन what is the value here. Okay, so this is what current source, but whose value depends on 2 into I1. मग तो ह्याला काय म्हणतो आपण? करंट डिपेंडंट करंट सोर्स. ओके, मग तुमचं क्वेश्चन आहे I1 कुठे आहे सर? वेअर इज I1? So I1 is the current flowing through this 4 ohm or here, like this we can use. So this is the current I1. I1 is current flowing in this loop. So if this I1 will change, the value of this dependent current source will also getting changed. So this is what the circuit given, and with respect to A and B, we have to find out the we have to find out the Thevenin's equivalent circuit. So how to find out? What is the first step? What is the first step? So we have to identify the type of circuit, whether it is belongs to type 1 or type 2. If I am observing here dependent source and one independent source, both are satisfying this condition. So this is the type 2. There should not be requirement you have to mention the type 1, type 2 कुठलाही ते मेन्शन करायची गरज नाही, but you have to identify. Okay. मग आपल्याला काय यूज करायचं आता? Given we can write as dependent source are present, dependent source is present म्हणून कारण एकच आहे. As dependent source is present, we have to apply Thevenin's theorem to find out Thevenin's the T capital पाहिजे. We have to apply Thevenin's theorem to find out following. To find out first one, VTH, that is nothing but open circuit voltage between A and B. Open circuit voltage between A and B. Next, second one, RTH. RTH is what? RTH ऐवजी पहिला आपल्याला काय काढावं लागेल? ISC. ISC we have to find out. ISC, that is what? Short circuit current. Short circuit current between A and B. And third one, RTH, that is equal to VTH divided by ISC. You can write, don't write RTH as a equivalent impedance. Actual meaning is that, but here we are not calculating in that manner. And fourth one is Thevenin's equivalent circuit. Thevenin's equivalent circuit. Thevenin's equivalent circuit. So this is what we have to find out. Now we can start from VTH. Okay, first point will be VTH. So for that purpose, we have to draw the diagram again, and you have to mark the open circuit voltage between A and B as a VTH. And then you can tell me which method we have to use to find out that VTH answer. So this is what 8 volt, this is 4 ohm. This is what 2 into I1. So between A and B, it is VTH. So open circuit voltage between A and B is nothing but VTH. So it is exactly parallel to what? Voltage across 2I1. म्हणजे मी इथं लिहितो VTH. Can I write like this with respect to this ground? This is what I1. A and B मधला voltage म्हणजेच current source च्या across चा voltage. Okay. Now tell me how to find out the VTH value. Whether we have to apply the KCL, nodal, what we have to apply?
Nodal analysis.
Nodal. Okay. So we can apply the nodal analysis here. इथला करंट किती असणार आहे मला सांगा? How much this current is? How much? Right hand side चा करंट किती असणार आहे?
I1 plus 2I1.
How? Open आहे ना इकडं?
Zero.
Zero, no. It is open. 0 ampere. Fundamentals विसरायचे नाही कधी. If it is open circuit, how current will flow? No, that is 0 only. Addition तो सांगतो बरोबर आहे I1 plus, but it is 0. Okay. Now here apply okay, apply nodal म्हणण्यापेक्षा आपण इथं KCL म्हणूया. Apply KCL at node VTH. कारण दोन इथं पण I1 आहे, इथं पण I1 आहे. Okay, and this current is 0. Outgoing we can show. So incoming is minus I1. Next, this current is minus 2I2, 2I1 plus 0 is equal to 0. These two currents are incoming and this is outgoing, we can consider. So minus I1 minus 2I1 is equal to 0. So minus 3I1 is equal to what? 0. If I1 is equal to 0 divided by minus 3 means 0. Okay, so this is my answer of I1. Now I1 I got 0. Now what is the value of VTH? Simply I will apply the Ohm's law between these 2 points. या दोन points मध्ये मी Ohm's law apply करतो. So by Ohm's law, 8 minus VTH, कारण VTH 0 sorry, VTH value मला काढायचे. 8 minus VTH divided by 4 is nothing but I1. बरोबर आहे? I1 चं डायरेक्शन बघा कसं आहे. त्यामुळे 8 minus VTH divided by 4, that is nothing but my current I1. So I1 I will put as a 0. So 8 minus VTH is equal to 4 into 0 is 0. So what is my answer of VTH? What is the answer of VTH? किती आलं? Anyone? Sonali Misa. Yes, please reply. Rutuja Mori, Sonali Misa, Pranali Misa, Disha Bhattad.
Eight.
Are you? Yes. So VTH is equal to what? 8 volt. 8 minus VTH is equal to 0 means VTH you can take right hand side, whatever you can do. So VTH I got 8 volt. VTH I got 8 volt. Okay. Now next step is what? ISC. I have to find out now ISC. So VTH, everyone understood how I got the VTH value? You can take 15 seconds. You can read it. I will give the time 15 seconds. काय केलं ते व्यवस्थित ऑब्झर्व करा. ऑब्झर्व द प्रॉपरली. Any questions now? Okay. So
No,
now
sir.
we have to find out now ISC. We have to find out now ISC. So for that purpose, what we have to do? We have to short the A and B terminals. A and B terminals मला शॉर्ट करायचे. त्या शॉर्ट सर्किट मधून जे करंट फ्लो होणार आहे ते मला कॅल्क्युलेट करायचे. Okay, so next task is to find out the ISC. Second one, ISC. Once again, I will write short circuit current. I already written here. Short circuit current between A and B. Now I will draw the circuit once again by shorting the A and B terminal. Please give me the attention here, everyone. This is 8 volt. This is 4 ohm. This is the current source, 2 into I1. I will short now A and B terminal. So many students are removing this current source. Short केल्यामुळे current source कसं हे होणार ना? Are you getting my point? If resistor is there, then it will get automatically open. But here, this current you have to find out, and this current is nothing but ISC between A and B. So this is 2i1 and इकडनं काय येते i1 येते. Okay, now very interesting it is. What is the voltage across this current source now? Who will tell? हे ज्यांना कळालं त्यांना हा प्रॉब्लेम सुटला. What is the voltage across this current source now?
8 volt.
Now 8 कसा असणार आहे? 8 is the open circuit voltage no. जेव्हा A and B ओपन होतात तेव्हा 8 होता. आता हा शॉर्ट केले. शॉर्ट केल्यानंतर किती असतं व्होल्टेज? या शॉर्ट पण मग 0 नो. सो दिस इज 0 व्होल्ट. मग या दोन पॉइंट मध्ये जर 0 असेल तर हे दोन पॉइंट पॅरललच आहेत ना याला. So can I write 0 volt here? Yes or no? पॅरलल सर्किट मध्ये व्होल्टेज सेम असतो ना. Yes or no? हे फक्त एक्सटेंड केलं A आणि B पॉइंट. If the voltage between this is due to what? Short circuit. बरोबर आहे? If it is short circuit then 0 volt. As A and B points are parallel to this current source, so voltage across current source is also 0 volt. So I will write here as short path have 0 volt, then voltage across current source is also 0 volt. Voltage across current source is also 0 volt. Now apply the KCL. Apply KCL at 0 volt here. At A म्हणा. Apply KCL at A. That is 0 volt. इथं हा पॉइंट पण जेवण Aच असणार आहे. Okay. So this point is also A point. So apply the case. This point is same as B point. कारण हा short है ना. So apply KCL at A. You can get now minus I1 incoming. This is the minus I1. This is the plus again minus 2I1. पण इकडे राइट हँड साइडला आता 0 नाही आहे, ISC आहे. Okay, that is the plus ISC is equal to 0. Minus I1 minus 2I1 is minus 3I1. Goes to the right hand side becomes 3I1. So ISC is equal to 3 into I1. इथपर्यंत मला आन्सर मिळालं. Okay. Now next point you can tell me now. Now how to find out the I1 value now? How to find out I1 value? Observe the circuit. I1 कुठे आहे बघा. या पाथ मधून या ब्रांच मधून तो फ्लो होते. इथे 8 volt आहे, इथे 0 आहे. So again you have to use Ohm's law. Okay. So now by using Ohm's law you can find out I1 value. By using Ohm's law, I1 is equal to, this current is equal to 8 minus 0 divided by 4. So that is my answer is 2 ampere. So put this in above equation. Therefore ISC is equal to 3 into 2. So ISC becomes what? 6 ampere. Now got the answer? ISC? Yes or no? Okay. So we got now ISC is equal to 6 ampere. Now next काय करायचं आपल्याला? RTH. We have to find out RTH and then Thevenin's equivalent circuit you have to draw here. So we can draw here in the left hand side. Okay. Now next point is Thevenin's equivalent circuit we have to draw. Third point is RTH. No, RTH we have to calculate. So RTH is equal to VTH divided by ISC. So my VTH answer is what? किती आला होता? 8. 8 divided by 6. So RTH answer is 1.33 ohm. That is my answer of RTH. Now next, fourth one, Thevenin's equivalent circuit you have to draw. So I will draw the Thevenin's equivalent circuit. Plus minus VTH is in series with RTH. There is no load resistor, so you have to keep open A and B terminal. So this is what RTH. So you have to mark the value. RTH is equal to 1.33 ohm and VTH is equal to 8 volt. So this is what Thevenin's equivalent circuit here. So take again 30 seconds. You can read each and every point how I calculated the ISC. ISC कसं calculate केले ते बघा. Okay, and if any questions will be there, you can ask. Okay. So the next now we can solve the next example. Question number 2 we can take. Question number 2. Okay. So obtain Thevenin's equivalent circuit. Obtain Thevenin's equivalent circuit. Obtain Thevenin's equivalent circuit for the network. For the network shown in figure. Obtain the Thevenin's equivalent circuit for the network shown in figure between load resistance resistor RL. So this is what question. So diagram you can observe. I will draw it. So it is 2 volt here. This is 2 ohm. There is current source here, independent current source having value 2 ampere. Next here 1 ohm. Here one dependent source is there. Polarity is there inside, that means it is a voltage source, but whose value depends on 4 into V1. So question is, where is the V1? Okay. So this is connected by load resistance RL. So V1 is nothing but voltage across this 2 ampere current source. V1 is nothing but this node voltage. म्हणजे इथला या पॉइंट या करंट सोर्सच्या अक्रॉस किंवा या ब्रांचच्या अक्रॉसचा व्होल्टेज चेंज झाला की या डिपेंडंट सोर्सचा व्हॅल्यू चेंज होतो. Okay, so they are clear cut mentioned here in the circuit diagram as well as question. Obtain Thevenin's equivalent circuit for the network shown in figure between load resistance. म्हणजे हे जे दोन पॉइंट तुम्हाला दिसतात, whatever you are observing these 2 points in across which the RL is connected, those 2 points you have to consider as a 2 terminals of the given network, and with respect to that you have to find out the VTH, RTH and Thevenin's equivalent circuit. So first task is what? Identify the type of circuit here. You have to classify it. So dependent source you are observing, independent sources 2 are there, dependent source 1 is there. So this belongs to what? Type 2. And first step is what? Remove that load resistor and make the two terminals open. So you can give the names A and B and you can start. So I will start now. This as dependent source is present. We have to find out. First one VTH, second one ISC, third one RTH, and fourth one Thevenins equivalent circuit. Thevenins equivalent circuit. So my first task is what? You have to open the two terminals A and B and find out the VTH. So first I am starting VTH to calculate. So this is what 2 ohm. This is what 2 volt. This current is 2 ampere. This is plus minus plus 4 into V1. This is open here. I will give the name as A and B. So this is 1 ohm. Now V1 I have to mention because 4 into V1 is there. That's why V1 I have to mention here. V1 with respect to this ground. So open circuit voltage between A and B is nothing but plus minus VTH. So how to find out VTH now? कोण सांगेल मला VTH कसं कॅल्क्युलेट करावं लागेल? How to find out? Which rule, which concept we have to apply to find out the VTH? Whether it is needed the V1 to calculate first. पहिला V1 कॅल्क्युलेट करावं लागेल का आपल्याला? कारण VTH बघा, VTH फाइंड आउट करण्यासाठी तुम्हाला KVL अप्लाय करावं लागेल या लूप मध्ये. मग KVL करायला यातलं करंट 0 असणार आहे. दिस इज ओपन सर्किट नो. मग ह्याच्यातलं व्होल्टेज काय असणार आहे? 0 व्होल्ट. So I will mark that voltage. This is 0 volt. Plus minus minus plus कसे? Because current is 0 ampere. Current 0 ampere असल्यामुळं if current is 0 ampere through open circuit, the meaning is that the voltage across 1 ohm is 0 volt. This already given 4 into V1. This is already given VTH, and voltage across this already given as a V1. My question is what? If you are finding out V1, you can get the answer of VTH. Then how to find out V1? That is my question. For that purpose, what I have to apply? Give the response first. How to find out the V1 here? V1 म्हणजे काय? नोड व्होल्टेज आहे ना? Yes or no?
Yes, sir.
So node voltage is there, then we have to use the nodal analysis. So apply the nodal analysis here to find out V1. Once you get the answer of V1, it is easy to apply the KVL in the second loop and you can get the answer of VTH. Okay, so nodal analysis in that apply KCL at node V1. त्यासाठी काय करावं लागेल तुम्हाला? Assume V1 is greater than 2 and mark the outgoing. Assume V1 is greater than 2. You have to mark the outgoing current. This is already incoming 2 ampere. आणि right side ला किती आहे? 0 ampere आहे कारण ओपन सर्किट आहे. Okay, so assume V1 is greater than 2 volt. That is what here expected. So V1 minus 2 divided by 2 ohm. Next minus 2 ampere. Next plus 0 is equal to 0. Next V1 minus 2 divided by 2 as it is. This minus 2 goes to the right hand side, becomes plus 2. Now V1 minus 2 is equal to 4. Current 2 into 2 4 होणार. So V1 is equal to -2 goes to the right hand side, becomes +2. So 4 plus 2 is 6 volt. So this is my answer of V1. Now once I will get the V1 is equal to 6 volt, I will write here 6 volt. Then you can apply, कारण इथं प्लस असणार, इथं मायनस, कारण 0 volt ग्राउंडला 0 volt, that is the negative. Now plus minus is here, minus plus is here. Now VTH is here. So apply the KVL in this loop. I will call it as second loop. So apply KVL, second point, apply Kirchhoff's voltage law in the loop 2. In loop 2. Okay. Now how to apply the KVL, that you know. 0 to V1 means minus to plus, that is the 6 volt. किंवा तुम्ही V1 लिहू शकता पहिल्यांदा. I will write minus to plus V1. Next plus to minus 0. Next minus to plus आहे त्यामुळे प्लस येणार. 4 into V1 आहे. या व्होल्टेज सोर्सचं व्हॅल्यू किती आहे? 4 into V1. नेक्स्ट प्लस टू मायनस आहे त्यामुळे मायनस VTH is equal to 0. So V1 plus 4V1 is 5V1 minus VTH is equal to 0. Therefore VTH is equal to 5V1. But V1 is what? 6 volt. So 5 into 6. So VTH answer is what? इथे आलं माझं VTH answer now. How much of value of VTH I am getting? 6 into 5 means 30 volt. So this is my answer of open circuit voltage across A and B. Okay, काय केलं मी? या VTH जर आन्सर फाइंड आउट करायचं असेल तर मला KVL पाहिजे. KVL अप्लाय करायला पाहिजे. ओके, मग 4V1 आहे, याच्या अक्रॉसचं व्होल्टेज V1 आहे, इथलं 0 हे कळायला पाहिजे, कारण ओपन सर्किट मधलं यातलं करंट काय 0 असणार आहे. If it is 0 means voltage is 0. So if I am getting the value of V1, then I can get the answer of VTH. Then how to get the V1? So think positively. V1 is the node voltage here. So you can find out by applying the KCL, you can find out that answer V1. So use nodal analysis and all those things. Then you can get V1 is 6 volt. And by applying the KVL in the second loop, you can get the VTH as a 30 volt. Now this is what the first step we have completed. The next step is what? We have to find out the ISC. That is somewhat difficult here. Once you get the ISC, next part is simple one. So that we can start now to find out the ISC. So that for that purpose, I will use same here, same circuit here. I have to short now A and B. मला A and B आता short करायचं आहे. So we have to complete this example today only, so that we can, in the next lecture, we can start the Norton's theorem. 3 problems we have solved based on the type 1, and 2 problems we are going to solve. Already one solved, and second we are solving. Once we complete these 2, now here we are calculating now ISC. So for that purpose, we have to short the A and B terminal. A and B terminal मला short करायचे. Okay. Now this V1 as it is here, V1 as it is. So if I am shorting this one, then the current which is flowing through this short path, that is now ISC. Now my question is how to find out this current ISC which is flowing through in this branch or through A and B. How we can find out ISC? Whether again we have to apply the, now in this case V1 value will be different. 6 volt will not come. It will be different value. So for that purpose, what we have to apply here? We have to apply again nodal analysis to find out the V1. Okay, so apply KCL at node V1. apply KCL at node V1. Apply KCL at node V1. So this is outgoing. You can mark this current by assuming V1 is greater than 2. This is also incoming 2 ampere, and this is the ISC you can take. Okay, V1 you can compare with 4V1 because this is the voltage source and in between resistor are already present. So assume that V1 is greater than 2 volt. Okay, now next V1 minus 2 divided by 2 because it is outgoing. Next minus 2 ampere. Next plus V1 minus of minus 4V1. काय आहे तिथे? कारण इथं मायनस आहे. V1 मायनस ऑफ मायनस प्लस पोलॅरिटी असल्यामुळे मायनस इथं आत येणार. V1 मायनस किंवा V1 प्लस 4V1 असंही घेऊ शकता. ओके, डिवायडेड बाय 1 ओम इज इक्वल टू 0. इथं काय केलंय बघा, इथं शक्यतो कसं असतं प्लस मायनस असतं. इथं V1 मायनस, इथं जर प्लस असेल तर आपण मायनस घेतो ना, V1 minus 2. But it already here minus is there. That's why V1 minus of minus 4V1. Value काय 4V1. Now LCM is, you can take LCM as 2. So multiply 1 here, multiply 2 here, multiply 2 here. So 1 into this bracket is V1 minus 2 as it is. Minus 2 into 2 is minus 4. 2 into in bracket V1 plus 4V1. कारण minus minus plus होतो. Divided by what? 2 is equal to 0. So 2 goes to the right hand side, becomes 0. So V1 plus 2V1 plus 4 म्हणजे 5V1 into 2 means 10. 10 plus 1 is 11V1. Minus 2 and minus 4, this gives the minus 6. Goes to the right hand side, becomes plus 6. Now here, if you are calculating, V1 is 6 divided by 11 means 0.545 volt. This is my answer of V1, but still we have not calculated ISC. So how to calculate ISC? Use the Ohm's law. V1 minus of minus 4V1 divided by 1. कारण इथं तुम्ही ते घेतलेलं आहे. This will give the ISC value. I will write here. This will give what? ISC value. Okay. Therefore now by Ohm's law, ISC is equal to V1 minus of minus 4V1 divided by 1 ohm. So V1 plus V1 minus of minus means 5V1. So 5 into V1 is 0.545. If you are going to calculate, so it will give what? ISC is equal to 2.73 ampere. So this I have calculated now, ISC. Now third step is we have to calculate RTH. So that is very simple. So RTH is equal to VTH divided by ISC. So VTH is how much? VTH किती आलता answer? 30. VTH is 30 volt divided by ISC is 2.73. So if I am calculating RTH, I will get 11 ohm. Nearby 11. Actually 10.98 येतो. So 10.98 is nothing but 11 ohm. So I got now all the values required for drawing the Thevenins equivalent circuit. Now I will draw the Thevenins equivalent circuit here. Thevenins equivalent circuit I will draw. So VTH in series with RTH across A and B. Across A and B. So this is what RTH. Now you can mention the values of VTH and RTH here. So VTH is 30 volt and RTH किती आलंय 11 ohm. VTH is 30 volt and RTH is 11 ohm. So this is what the Thevenins equivalent circuit for this question. So if any questions will be there, you can ask. Otherwise we can stop for today. कोणाला काही questions असतील? So 2 examples are sufficient. More examples I have solved. and given in the study material sheet. You can refer that sheet. You can refer those notes. And many examples I have mentioned in the assignment booklet. You can try to solve those examples which are based on type 1 as well as type 2. So if any questions, any doubts regarding the Thevenin's theorem related to type 1, type 2, whatever it may be, you can ask. If no, you can say no, we can stop it. काय तर response द्या. Everyone is in only listening mode. This is for you people only. Okay.